In question 4, we're given points A and B. A has the coordinates at 14, 3, and B has coordinates at 21, 8. And we're asked to find three different things. We're asked to find the equation of the line that would pass through both of those points. We're asked to find the length of line segment AB. How far is it to travel from A to B? And then finally, we're asked to locate the midpoint of segment AB. So let's go ahead and I'll increase this a bit here. And kind of a standard problem for us at this point, right? If I want to find the slope, the equation of a line, I'm going to begin by finding the slope of that line. And in order to find the slope, I need to find the difference in the y values. So you can see here's 8 and here's 3. And I need to find the difference in the x values. Here's 21 and here's 14. So the difference between numbers is, calculated by using subtraction. So if I want to find the difference between 8 and 3, I can take 8 minus 3. So I'm going to write 8 minus 3. So that's the change in y. That's it's going from 3 to 8. So 8 minus 3 gives me a change in y of 5 units. And then same thing for x. I'm going to take 21 minus 14, and you'll notice that I'm going the same direction each time. I'm starting from point B, and I'm subtracting the corresponding coordinate from, or the corresponding value from A. So 8 minus 3, 21 minus 14. And of course the 21 minus 14 gives me 7. So I have a slope here of up 5 over 7. And that's certainly going to be part of my answer, but it's not my answer yet. The next thing I need to do is figure out the y-intercept. And I think probably still my favorite way to do this is just to consider a generic line, y equals mx plus b. And I know one of the parameters is 5/7, but I don't know the other parameter. I don't know b. Right? This parameter b is unknown. And what I'm going to do is just grab a value of x and y from one of my 2 points. I'll pick point A, and I'm going to plug in 3, that's my y value from that point, and 14 is the x value from that point. So using that point and the slope, it's going to allow me to figure out what my y-intercept is. If I take 5/7 and I multiply it by 14, my favorite way to look at that is 5 times 14 all over 7. And if I look at it, there's clearly a giant 1 here, right? 14 is a 2 times 7. So because there's this value of 1, 7 over 7, this just becomes the number 10. So this is 3 equals 10, and then plus b. And to solve for b, I'm just subtracting 10 from both sides. 3 minus 10 is a negative 7. So b is negative 7. I know both my y-intercept at this point, and I know the slope, so I can write the equation of the line. The answer to this would be y equals 5/7 up 5 over 7 times x, and then minus 7. So this is the equation of this line. And one of the things that has to be true, just as a check here, is if this really is the equation of the line, both of these points have to satisfy this line. When I plug the x and y values in, it should make it true. And you can verify that, I've already done this with, I kind of already did it with the first point, right? But if I take 5/7 times 14, that gives me 10, and 10 minus 7 is indeed 3. So it clearly checks there. Do the same thing with the 21. 5/7 times 21, I would just take the 20, let me write it for you, 5/7 times 21. I know that 21 divided by 7 is 3, so this becomes the number 15. And, 21 divided by 7 is 3. And 3 times 5 is 15. So what I have here is 15, and y should be 15 minus 7. And yeah, when I take 15 and subtract the 7, I get 8, which is perfect because that's what y should be. That was a little convoluted. But anyways, when I do plug in the value of 21 into this equation, it gives me 8, and when I plug in the value of 14, it produces y as 3. So this is clearly the equation that goes through those 2 points. The next thing we want to do is attempt to find the length of the line segment here, and
this is just I'm going to use the Pythagorean theorem, but just kind of to orient myself here, I'm just going to go ahead and sketch roughly A and B. So A is over 14 and up 3. B is over 21. Let me make this a smaller scale. So A is over 14 and then up 3, and B is over 21 and up 8. So that's roughly where they're at. I'm going to change the scale again. Actually, I'm going to remove the scale. I'm just going to say, hey, here's point A and here's point B. I'll exaggerate the scale. B is at 21 comma 8 and A is at 14 3. So what I'm trying to do is figure out how far apart they are, and I'm going to use the Pythagorean theorem. In order to answer this question, I need to figure out the length of these legs. And I can see that one of the legs is x value ends at 8 and it started at 3. I'm sorry, these are the y values. So for y to go from 3 to 8, there has to be a change of 5 units here. So one of my dimensions, this leg, is 5 units long. My other leg I can see is starting at 14, and it's going to the number 21. And if I take 21 and subtract 14 from it, I get 7. So this particular leg has a length of 7 units. So you can see I've got the two sides of this right triangle. To figure out the length of this segment, I'm just going to use the Pythagorean theorem. I guess I'll call this third side x right now. So if I was to square that, it should be the same thing as 7 squared plus 5 squared. So this is just the statement of the Pythagorean theorem. The length of the hypotenuse is equal to the sum of the lengths the sum of the squares of the lengths of the two legs. This is 49 plus 25. If I add those two numbers together, I believe I get 74. So what I have here is that x, if I take the square root of both sides, x should be the same as root 74. And actually, that's a fine answer. I like this. It's an exact answer. And I don't think there's any perfect squares inside of there, so that it would actually be a simplified radical form. But I'm going to go ahead and take the square root as well, and I'll say this is also about 8.6. And units long, right? It's a kind of, I guess it's important I say that. There's no sense about how far apart the Cartesian plane is here, like how big each unit is. But whatever it is it's 8.6 units long. And if the units are miles, it would be miles or whatever. All right, final point here is find the midpoint. So I kind of like that I have the sketch from the previous part. So if I'm trying to find the midpoint, my goal is to find the location of this thing right here. And I think probably the most efficient way to do that is to think about the average of these, because what is in between two things, two numbers, is the average of those numbers. So for example, if I wanted to find the average of the y values, or let's do the x values first. So we're going to figure out the average of the x values. I know this is 7 long, and you know what? Half of that is 3.5. I could start at 14 and add 3.5, but I'm going to go ahead and go this way. I'm going to say let's look at 14 plus 21, and I'll divide that by 2. Well, if I take 14 and 21 and add them together, I believe I get 35. And 35 halves, it turns out, is the value of x at this point. 35 halves, which is, if I was to convert that to a decimal, it's exactly 17.5. So if you think about that, yeah, I have to start at 14 for x, and I'm going to move 3.5 units over. And 14 plus 3.5 is indeed 17.5. So I know my x value is 17.5 at the midpoint. I'm going to do something similar for the y. So for my y's, again, I'm trying to figure out what the halfway mark is here for this. And you can see that I'm starting at a y value of 3 and going to 8. So I'm just going to take the average of those, 3 plus 8, divide by 2. 3 plus 8 is 8, 9, 10, 11. So this is 11 halves. Which is what, 5.5, 5.5. So the midpoint for my y is at 5.5, and you can again look at this. If this is 5 units long, half of that is 2.5. So if I start here where y is 3 and go up, right, at 3, 4, 5, 5.5. I landed exactly 5.5. So I kind of like finding the average of the endpoints as one way to do it, but I always want you to try and think about what's happening, and don't just get to where we're just engaged in some rote memorization of a formula, but think about um, why we're doing what we're doing and what exactly we're doing. So, and if I was going to record this as my answer, then the midpoint has an x value of 5.5, and I'm sorry, I got that backwards. The x value is at 17 and a half, and the y value is at 5.5. So this is the location of the midpoint.